Right. Hello and welcome to Let's Learn. So today we'll be looking at the new KSSM format for Form 4 Maths. Alright. So today we'll be covering Chapter 5, alright, the summary of Chapter 5. It's not too difficult. It's more logical. Alright, and don't be scared by it just because it's called network in graph theory. Okay, yes, we can apply it for complicated things, but what you have here are the simple stuff. Right, don't be scared by it. As long as you have common sense, it's fine, right? And everybody has common sense. So, what for network in graph, you will have a simple and a not so simple one, right? Where they have loops and multiple edges. So the loops would be these circles, right? And the multiple edges would be when you can see these 2 points, they have 2 lines connecting, to both of them, right? It's not like, oh, I'm going there, but it's basically I come here and then you go there. It's connecting 2 points with 2 lines, and that's why you have the curves, right? Nothing special about it. The reason why is it curved and why there are others are straight is because if you draw 2 straight lines here, then it will just look like a very thick single line. Alright. Now, for these graphs, right, we have undirected graph as well as a directed graph. Right, directed graph means it has direction. That's it. Right, undirected graphs, no direction. It's kind of like vectors and what do you call the normal numbers without directions. Oh dear, I forgot. Anyways, it's in physics if you want to know. Yes, scalar, right? So you can consider this like vectors, and this is scalar, where there is no direction, right? Scalar only has magnitude. Vectors have magnitude and direction. Okay, so weighted graph would be when each edge, right, the lines are called edges, the vertices are the corners, right? So like this is one vertex, that's another vertex, this is another vertex, that's another vertex. Okay, and then let's see, you have edges, corners, and loops, which are the circles. Now for degrees, basically what it means is if you look at every single node, which are the dots, right? Like for example, this directed graph, right? If I take this as the first node, right? I have 2 lines connected to it, right? So that's 2. Then this one another 2. This one has 1, 2, 3, 4. Because of the circle, that the circle will have 1, and then as it goes back, another 1, right? So if you add all of them up, right, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So just in this graph we have 16 degrees. Okay, you have the formula as well. Kind of forgot what is it, but you can always look back. Of course, you need to remember. I don't have to. I'm way past all of this. I just do this by instinct now. Right? Why do I do this by instinct? It's because, well, when you're at a certain level, you don't have to remember everything. Oh, where are they? Did I miss it? Oh, you have the formula here somewhere. Degree. There. The sum of degree is equals to 2 times the edges. Okay? Alright. Now let's go back to this one. So unweighted graph would be the edges are not labeled at all. The tree diagram, very simple. You most probably have done it in probability before, right? Where you split up 1, 2, 3, and then, or maybe let's say someone plays a game. The probability of winning a game is 1/3, and the probability of losing is 2/3. Right? So, what's the chances of the person winning 3 consecutive games? So it'll be 1/3 times 1/3 times 1/3, right? Because you have 1/3, 2/3, and then another 1/3, 2/3, 1/3, 2/3, right? So they keep splitting up. So that is your tree diagram. Now, the subgraph, however, is an easy one. So they give us 2 samples of subgraphs, right? So 2 samples of graph, and the subgraphs of each one of them, right? It can be a single line forming from P and Q. So you have to draw the curve. The reason why is because you have 2 lines connecting P and Q together, right? So any, iteration, that means any kind of partial drawing of the complete graph is called a subgraph. Right? For example, this triangle, as long as you don't connect Q and R, this drawing here is considered a subgraph for this graph. Alright? So you have Q and R, P and R, and you can see the positions are where they're supposed to be. Right? If Q is on top of P, then Q is supposed to be on top of P. Nowhere else. Right? Right? If you have Q on the top left of R, then Q must always be on the top left of R. Right? It cannot be Q is, directly above R or even on the right side of R. So that's just it. That's the end of your network in graph theory. Right? It's just common sense. You just have to be very careful of what you have drawn, right? And plan out what you want to draw first before you really, settle down to your final graph. Right? Once you fully understood what the question wanted, then the full picture will come to you just like that. Right? If you can't really understand it, then go sentence by sentence to understand what they really want. Alright? So I hope you can understand this chapter if this is relatively new. Okay? Relatively new in the sense that it's new for secondary school students. Alright? But for those who are studying diploma or degree, this just falls into place, right? It's pretty much instinctive. I believe computer science students are taught this. I'm not a computer science student. I'm an engineering student. So yeah, I remember learning something like this in AI, but we didn't really touch it. It's just more of they expect us to know because it's common sense, right? So don't be afraid of it because it is common sense. You just need to understand it and work your way out. Alright, so I hope you can understand this, and I hope it has helped you. Right, remember to share the video, subscribe, click on the bell icon, put up the thumbs up, right, if it really helped you. And I hope to see you in the next video. Bye!